Hello everybody. In this video we're going to talk about movement. How are we going to get the square that we've created in our grid in our 248 game to move from one side of the screen to the other? Now, movement is really important because that's what adds animation, what adds life to a game, and that's part of what makes the game fun. If we haven't met, my name is David. I have 15 years experience of building video games, both on computer, on mobile, on console. And for me, coding is a game. Coding is fun. And it's a game of the imagination. It's a game of construction. It's a game of logic. And my passion is to share the joy of code. So, without further ado, come play with me. So this is where we're at. We have created a grid in which we have placed a square. Here, we've placed the square. I moved it around a bit from last video so we can have it not on the edge. And here we have the detection of the movements right, left, up and down, which is an event listener, which is on the background of this grid here. Now what we want to do is, in this function up here, which creates the square, we want to start by storing the current column and line of the square. So we have col equals col and square line equals line. Now we're going to add a function, actually two functions on this square, which allow us to move it to a certain line or to a certain column. And so it's interesting to keep the square keep in mind where it's at on the grid. So function move, actually not, square move to col, and then we're going to have a col as a parameter, and end. Sorry, this function we've used the notation here with a colon, and this allows an implicit first parameter of the function to be the object calling the function that has the function itself. So this means that here I have access to a variable called self, which is actually the square itself. And if column is not equal to column, then what we're going to do is we're going to use the transition library, transition to, and we're going to transition the square itself, so square, and then we're going to pass in a number of parameters, and the first parameter is the variable that we're going to move. So we're moving the columns, so we're moving x to here, column times slice. So we've created so here we've moved the x equals column. Now the interesting thing is to store the new position on the in the square. So we're going to do self column equals column. Now I'm just going to change, sorry, this the variable we're passing here inside the function, because just so that we can identify which variable is being used. It's actually LUA works out fine, just in terms of readability it's better. And we're going to do the same thing. We're going to do the same thing for the line, but first I want to adjust this function before I copy paste it. So move to column, that's going to be for the left right. So we're going to go here in the moving right. We're going to go square, move to column 3, and left we're going to do square, move to column 0, right, left, and that's right. So I'm just going to reload that and see how it works. Read launch simulator, start, going right, there we go, going left. Okay, not too bad. The one thing you might have noticed is that going right was a lot faster than going left. The reason for this is that here in our movement, there's actually an implicit parameter here, time equals, which is set to a default. I can't remember exactly what the default is, but it's, for example, we have here time equals 500, and what I'm actually going to do is I'm going to define a global variable here, local time equals, I don't know, 250, now that I have the same variable. And actually here, the interesting thing here is for the time to actually depend on the distance traveled so that they have the same speed. So I'm going to do, it's going to be time times the absolute, math absolute of call minus self call. There we go. Math. There we go. And now what we're going to do is duplicate this for lines. So here we go. And there we go. It's duplicated. No, I've actually edited, but I've switched out lines and columns, and I've switched out Y and X. And so we should be good to go here. And I'm just going to implement it here. So we have, if we're going down, square move to line 3 and square move to line 0. Let's just try this out. So relaunch simulator, start, going right, going up, going down, going left. Now we could probably speed this up a little bit. But there's another thing I wanted to show you is the transitions. Now transitions are functions that allow you to change the way the movement is. So it's not just a linear start here, move, go to the end, but they can be more interesting, have a sort of speed up and slow down, that kind of stuff. One that could be interesting here, for example, is a bounce. So here we'll try this out using out bounce. And this, in the same way as I've done earlier here, I'm gonna do local easing equals easing dot, sorry. There we go. And now this variable I'm going to use here with transition equals this, and the same transition equals this. There we go. Oh, and then boink, 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 boink. So it means it's fairly easy to add something interesting to the animation. Right, so I hope this has been helpful. It's, as you can see, it's really easy just to add movement to the screen, and it's easy to make it interesting, to add variations to that movement, so it's not just simple movement, but it has animation to it. And like I said at the start, this allows us to make the game itself fun because it gives life. If you like this video, if you got value from this video, please subscribe, please like the video, and we're going to be continuing our journey of building the 2048 application in further videos. So stay tuned and see you soon. Thanks. Bye. Is it finished yet? Stop.